Welcome to your first lesson in trigonometry. We are going to start with the tangent ratio. In right angle trigonometry, we have three primary ratios that we're going to use, and we're going to start with the tangent one. All of our ratios are going to be described from the acute angles in the triangle. Looking at tan A, we deal with opposite over adjacent, so another way to write this is tan A is equal to op over adjacent. So if we're just finding the tangent ratio, we're looking for in decimal form or in fractional form. So let's start with angle G. If we're looking for tangent of G, our opposite is 18, our adjacent is 10, which simplifies to 9 over 5. If we were looking at tangent of F, that should be 10 over 5, sorry. Let's do that again. Tangent of F is 10 over 18, which gives us 5 over 9. And these guys should be inverses of each other, so they should be the same value, just flipped. Now we're going to take those ratios and we're going to turn them into angles. So starting at angle A, drawing our line directly opposite and directly adjacent. Tangent A is equal to 16 over 7. We're going to use a new button on the calculator called tangent inverse. It looks like tan to the -1 because that is the opposite in operation here. So that looks like this now. Angle A is equal to tan inverse of 16 over 7. We plug that into our calculator using the shift key to get that value in there. So shift tan or second tan, 16 divided by 7, which should give us 66 degrees. What if you were asked to find the measure of angle A and angle C? Would you need to use the tangent ratio twice? No, but it's not always good to recycle math. Because what if you did it wrong? To recycle math. And remember that all triangles equal 180 degrees, which is why we could do that, because we could just subtract values using that. Our angle of inclination is the acute angle between the horizontal and a line segment, this being horizontal, and this being my line segment. Definitely does not connect, but you get the idea. A guy wire is fastened to a cell phone tower 8.5 meters above the ground. We pretty much can always assume that these are going to look like right triangles. So it is 8.5 meters above the ground, and it's 14 meters from the base of the tower. What angle to the nearest degree does a wire make with the ground? Now, because this triangle is not labeled, we can use the Greek letter theta to indicate angle. So we set this up as tangent of theta is equal to opposite of 8.5 over 14. We take the inverse of both sides. Which leaves us with theta is equal to tan inverse of 8.5 over 14. So we go shift tan of 8.5 divided by 14, which gets us 31 degrees. Okay, last one. A support cable is anchored to the ground. Another cable, another anchoring. Doesn't matter how bad your sketch is, as long as you have this little guy right here, it's going to make me realize that you're trying to draw a right angle triangle. It's 5 meters from the base of the pole. The cable is 19 meters long. First step I can see that's already wrong is that if we're trying to find this angle, we don't have our opposite. So we need to use Pythagorean. So a squared plus b squared is equal to c squared. A squared, remembering that this is a, c, b, plus 5 squared is equal to 19 squared. A squared plus 25 is equal to 361. Now we need to get a by itself before we're allowed to square roots. We're going to subtract 25 from both sides. That gives us a squared is equal to 336. We're going to square root both sides. A is equal to the square root of 336, which is 18.3303. So now we can use that information for our second step. Tangent theta is equal to opposite, which is 18.3303, over our adjacent, which is 5. I don't know why I put meters there. No, redo that. There. There we go. Okay. We take the inverse of both sides. Which leaves us with theta is equal to tan inverse of 18.3303 all over 5. We plug that into the calculator and we should get 75 degrees. Next, we will learn about the tangent ratio and how to use it to find lengths, not just degree angles.